Hello all, very good morning. Thanks for joining the session. Let me share my screen. Yeah. So today let us discuss about the microservices patterns, course content, like what we will cover and all. And also we will see the microservices. What are microservices? So the course content has been designed in such a way there is a problem and then a solution has been also proposed. So if you can see my screen, this is the microservices patterns content. Nowadays, interviewers are pretty much interested in knowing the knowledge or experience of a candidate on the microservices. So they not only asking what are microservices and all, they are also asking how the microservices were implemented and then the problems faced in implementing the microservices and the solutions that we were applied to the problem to get it resolved is what the microservices patterns will explain. So microservices patterns, I'll explain what is microservices and all. So if you can see my screen, this is our course content, microservices patterns. We'll see the decomposition patterns, decomposed by business capability, decomposed by subdomain, and triangular pattern. So this design pattern, decomposition pattern, will explain us how an existing application can be converted into the microservices. How an existing application will be converted into the microservices. That is what the decomposition pattern. That means existing application may have the code in a single application. For example, if you see my screen, so we have the functionality of the customers, functionality of the orders, functionality of authentication, right? So all these things, first of all, customers, home, orders, authentication, and others also like products, categories, and orders. All the modules are in a single application, correct? So all these models, all these features are in a single application. So this application is called as the monolithic or monolith application. So this application is called as monolithic or monolith application. So such monolith or monolithic application in architecture wise, it is like this. Such monolith application. This is the monolith application design, right? So all the modules and the module specific layers also. We know every application will follows the entire architecture, isn't it? To call an application as an enterprise application, it should follow the entire architecture. So let me go and then showcase you another architecture diagram just in a moment of time. Yes, architecture flow diagrams. Let me open this diagram. Yeah, if you can see this diagram, we have the categories module, we have the products module, and we have the orders module. So categories module, products module, orders module again have their own specific directory or package structures, like categories controller, categories service, categories model, categories repository, categories bean, like that. So product also having a product controller, product service, product repository, product model. So orders also having the various layers. So for all these orders management, products management, categories management, all these are inside a single var file, and all these are connecting to the database, external database. All these modules are using a single database, correct? So 2 points here we need to understand. Number one, all the application modules are bundled in a single application server, meaning all the application modules are bundled in a single archive, that is var or jar. So these are the points that we need to understand. So let me write down the points just in a moment of time. Just let me write down all those points. Fine. One moment. Fine. So date is 29 June 2022. Topic is microservices patterns. Okay. In this microservices patterns, what we are trying to understand? We are trying to understand monolithic or monolith application. So what I'm saying is, if the all the Spring Boot, sorry, if the all application, if all application modules are bundling as a single var, single archive, that is var or jar, then we can call it as a monolith application, right? Monolith application. That means all the modules are bundled as a jar or var. For example, as I have shown here, these are all the modules. These are all the modules were bundled as a single var file or jar file. So now the single jar file or var file, when you can see, contains all the modules inside in it. See this COM, Shopify, platform. So all the modules are here. Features, all the modules are here. So if all the modules are bundled as a single archive, right, then that is called as the monolithic application. These monolithic applications contains all the modules, right? Contains all the modules inside a single archive. Single archive will use the same process boundary. Use the same process boundary. These monolithic, what I can do is these modules inside the monolithic applications, right? Monolithic applications, modules inside the monolithic application, inside a single archive will use the same process boundary of an application server or a web server. What is this point meaning for? What is this point meaning for is these jar file or var file, whatever we prepared, which contains all the modules inside in it, will be deployed when then all these modules will use the same process boundary. What does it mean is, now I'm running this application. Carefully observe, please. When I'm running this application, there is a process created. That process only will be used by all these modules. So that means all the modules within the same process boundary. So let the application be start. Let the application be start. Yes, application is started. Now if you can see here, there is a process created with the process ID 8028. There is one process created. So inside that process, all the modules are using, or all the modules were inside that process. So that means what? All the modules inside. So all the modules inside the monolithic applications in a single archive, will use the same process boundary of an application or web server, right? So when we start, a process boundary has been created, a process has been created. Within this process, all the modules will be there. So the diagram for that is this one. This box you can see, na? This outer box with this tomcat symbol. This is nothing but the process. This is nothing but the process. So in this process, the var file has been extracted, which contains the many modules of the application. Now all the modules were there inside a single process boundary and started connecting to only one database, meaning all these modules are sharing the database. So this is called as what? Monolithic applications. So these are called as what? Monolithic applications. So we have the problems in this monolithic applications. Number one problem is cascading failures. So this is the biggest drawback of the monolithic application architecture. What are these cascading failures? See this: orders management, products management, categories management, etc. are using the same process, isn't it? Same process boundary. Now assume, due to some reason, when these categories are fetching the data from the database, it got some fatal error. It got some error. Maybe that error because of the data also. This data, when this data will be fed into the database, assume the case there is some third-party system which will dump the orders data. What is mean? Assume our application have the franchises. Let me showcase you first the application, how it will be. Then let us see that case. So localhost 8080. So this is what our application. Let me log in, admin and then admin. Yes, this is our application. And in the application, we have the customers. So these are the customers. Assume These customers were created by some other system also. Some franchises we have, that franchise is also using this application, where the customers will be created into our application by that franchises application. Assume, right? Then they were given some wrong data, just in case. They were directly given the data into some database, right? So this database data, when we are fetching the customers, then when we are fetching the customers from the database, like when we have clicked on it, one moment. Sorry. So when we are fetching the, when we clicked on the view customers, sorry. So when we clicked on the view customers, all the customers related data that we are getting. And we can even filter the data based on the customer's mobile number or email, whatever it is. Assume due to some wrong data fed into the database, when the fetching the customers, we got some error. That is a fatal error. Assume fatal error meaning we cannot move ahead. Server will stuck there, and then server process will also be killed. So as a result, when we access the application, it won't access to us. Are you getting my point? So what is the cascading failure meaning? All the modules are using the same database, and all the modules are using the same process boundary. So if one of the module will fail, entire application will fail. So products module is doing good, categories module is doing good, but though they are good, the issue in orders management causes this application process to be killed, and as a result, the other modules also won't get accessible. So this is called as the cascading failures. When there was an fatal error, when there was an fatal error occurred in one module, in one of the module of the application, causes the entire modules to be unavailable by making the process killed. Got my point, right? When there was a fatal error occurred in one of the modules of the application, causes all the other modules also to be unavailable. By making the process killed. Hope you got this point. Cascading failure meaning if one of the module will fail, all the modules will fail. The one of the module will fail, all the module will fail. That is what the cascading. Then second one is performance. Second one is performance. Assume when we have the transactions, right? So every application, every enterprise application needs to use the transaction management for the data rollbacks and for the data consistency. You can say simple For the data consistency, every application should have to use the transactions. So every enterprise application needs to use the transaction management for the data consistency. Assume if any one of the module is with the isolation level serializable. Assume if any one of the module is with the isolation serializable, then while retrieving the data or creating the data, that module will apply the lock on the database. Lock on the database. That means what? Assume the orders management is using the isolation serializable level. The transaction management level is the transaction definition level is the isolation level is the serializable. That means what? While this orders management is retrieving the data or creating the data in the database, it will apply the lock on entire database. As a result, what will happen in the same time, if the products module or the categories modules will talk to the database to get the data or to create the data, these will be in the waiting state. That means when customers will click on the product management, the page will be like, spinning, but the products dashboard won't come until the orders management will complete its job. So these are the possibilities that we have. So assume if any one of the module is with the isolation serializable level, then while retrieving the data or creating the data, that module will apply the lock on the entire database, table. What I mean to say is entire database table. Again, don't confuse, not on the entire database, only on the entire database table. During the same time, if any other module is trying to get the data, like want to see the order pivot. That means purchase order. Want to see the purchase order pivot. Want to see the purchase order, right? Want to see the purchase order. If any other module is trying to get the data, like want to see the purchase order of a particular product, okay? Particular product. What did you understand now? When we click on the product, our application is like this. So when we click on the products, for example, we have the new arrivals and then we'll try or the pending products, whatever it is. So these trending products are there and the new arrivals are there, and then the virtual try is there, and also the products will also be there. For example, if you click on the products, actually this module is not implemented, but if you click on the products will display like this. So when we would like to see the products for a particular product, we also would like to see its product purchase order, PO. That means what? When we are getting the data of a particular product, sometimes we also need to get the order copy of that product. But that order copy is in the order database. Meaning order table. So product management also would like to lift the data from the order table. but order table is locked already by the order management module. As a result, what will happen? Product management module will wait till the order management module completes its transaction. So assume if any one of the module is with the isolation level serializable, then while retrieving the data or creating the data, that module will apply the lock on the entire database table. So during the same time, if any other module is trying to get the data, like want to see the order copy of a particular product, then the product module, while lifting the data from the orders table will be in waiting state, till the orders module release the lock on the orders table. So this will be a serious performance. This will be a serious performance concern, right? This will be a serious performance concern of the product module. Got it? So there will be a serious performance concern on the product module, because product module will always be, most of the times product module, when we click on the view purchasing order of a particular product, when we click on the view purchasing order of a particular product, that will be always in a waiting state. Rather giving the data, always it will be spin, meaning the browser will be shown like spinning, but no products will be displayed, or no products orders will be displayed. So that is the serious performance concern. So these are the problems with the monolithic application, right? So these are all the problems with the monolithic application. So the solution for these monolithic application problems were given by the microservices. So if you can see, these are all the problems. So monolithic design services. So this is the monolithic architecture, traditional monolithic architecture. So the traditional monolithic architecture has been evolved into the service oriented architecture as well. Maybe my terminology might little new to you, but let me try to explain you what it is. Okay, so these are the two problems we got, right? And then third problem is what you know, too much of database tables overhead, too much of database tables with the joins, too much of database tables with the joins overhead. So that means if we use the same database, right, which contains all the tables, then those are all the tables will be joined with the many complex relations. For example, just now we have seen a product will have one order, right? One product will have one order, and one product will be in one category. One product will be in the one category. So one product will be in the one category, and one product will have the one order. So minimum one order, and then one order contains the many products. Maybe a single order copy we can take, where we might have ordered the many products inside it, right? And for example, payments module, if you can see payments module, one payment nothing but one order copy. For each and every order copy, there will be one payment, where this each and every order may contains one or many products. If we can see this product category, order category, payments. So these are all what actually the complex relations, if we can see, right? So product may contains one product, may contains one order, and then one products fall into one category, and then the orders, maybe one order maybe for many products, and one payment for one order, where one order contains many products. So these are all what complex relations, joins that were applied on the tables. So too much of database tables with the joins overhead the application performance. Overhead the application performance. Application performance. And then what is the other problem? As all the modules were bundled in a single archive, the start time, the bootstrapping time, also will be more. Also will be more bootstrapping time when deploying the application in the application servers. Also, yes, can you please mute? Thanks. Also will be more. So these are all the problems that we can see in the monolithic architecture. The main problem is cascading problem. So these are all the problems in monolithic application architecture. Then what is the solution? What is the solution for these problems? Decompose the possible modules into independently self-executable autonomous microservices. What does this mean? Maybe you might not understand at this moment in a single class, but the idea is what break down the application into a similar small applications. Break down the application into small applications, and then the small applications will be self-executable and then the autonomous. That means they will be executable inside their own server. What does it mean is, so this is the meaning of it. This is the meaning of it. So take the orders module as one application. Yes, can you please mute? Thanks. So take orders management as one small or single application. Take the categories management into one small and single application. Take the customers into one small and then single application, which is having their own databases. So this design, this architecture solves the above said problems. Problem number one, cascading failure. As each and every application, app 1, app 2, app 3, are there inside their own process boundary. That means they might be run inside their own Tomcat. If the app 3 will down, no problem. App 2, app 1 will still run because they are running in their own process boundaries. Isn't it? They are running in their own process boundaries. If the app 1 will down, no problem. App 2, app 3 will still run. For example, if the orders might down, no problem. Products will be still shown, but the product purchasing orders might not be shown at this moment. Isn't it? Category is down, no problem. Products will be still displayed to the customer, but the product belongs to which category, that might be blank, that might be not shown, but application will still run. Earlier case, the problem is one module causes the other modules to be stopped, but now the problem in one module never affect the other modules, because each and every module is running as a separate, independently executable application. Independently executable, independently deployable, self-executable application. That means this have its own server. In that server, it is running. Categories have its own server. In that server, it is running. Orders are having its own server. In that server, it is running. Orders having the own database. Product having the own database. Categories having the own database. It is altogether a separate, independently executable application, right? So causing the failure in one microservice should not affect in another microservice. This is the beautiful help or the design, the beautiful advantage that we will get with this microservices architecture. Second, assume the orders is with the serialization isolation level. So that serialization isolation level log the orders database only. No problem. Still the product is not locked. Still the categories is not locked. They will work as expected with high performance. Right? Maybe there will be some degrade we can see. Even some degrade also we don't see. Meaning when the product is clicking on the view purchase order, it will now don't wait, no, it will don't spin, because it will go to the orders management, get the ordered copy of a particular product. So order management have the lock on the orders DB only, but product don't have any impact of this locking the database table to the product. So the performance problem with this, with this foreign key or whatever the kind of associations are now removed. Now next, too much of database joins. No, each and every application have their own database. There is no concept of joins in this microservices architecture. So the overhead of the joins were completely removed in the microservices architecture. Now the above said problems were easily addressing using this microservices. So what are microservices? What are microservices? Microservices are a small or tiny applications which will be carefully observed, which will be self-executable, independently deployable, and autonomous. So this is called as a microservice. Microservices are a small or tiny applications which will be self-executable. That means they will run in their own process boundary like Tomcat, and which are independently deployable, However, as they have their own Tomcat application, in that they have their own Tomcat server. For example, orders management have their own Tomcat, right? And then the product management have their own Tomcat. Categories have their own Tomcat. So as they have their own Tomcat server, these applications will be deployed in the same, their own Tomcat servers, right? That is called what, independently deployable and self-executable. Why self-executable? These microservices having its own Tomcat server or some container, I could say. In that server, the microservice is executing and autonomous. Why we are saying it as an autonomous? Because each and every application will have its own JRE or JDK. Each and every application have its own Tomcat or any other web server, and each and every application or microservice have its own code, meaning the source code, its own code, meaning the source code related to only a microservice, only a microservice business, only a microservice specific business, microservice specific business. What does it mean? Example, what does it mean? Orders service will have only the order management related source code, order management related source code. Similarly, product management will have only the product management related source code. So this is one example. That means it have the orders controller, orders service, orders repository, orders model, and then orders bean, right? Then orders commons, etc. But it didn't have the product related source code anywhere, or it didn't have the product related referential integrities anywhere. No, there is no other entity or other business component reference in this order service. So it's having its own code, it's having its own JDK, JR, it's having its own Tomcat or other web server, and it's having its own process, right? Because it's having its own Tomcat when we start it. So its own process, its own process ID, right? So that is the reason these are called as an autonomous. And here, this functionality, this is called as the single responsibility. So if a microservice having its own specific code, like orders controller, order service, orders repository, orders module, orders bin, if it contains only related to the order service related things, then that is called single responsibility. Right? That means single responsibility. So all the microservices are single responsibility services. So all the microservices are single responsibility services. So we will discuss later in time about the solid design pattern. Not pattern, solid is a design principle. So derived from the solid design principle. Solid design principle. What is the solid design principles? We will see later in time. Meaning when the situation will come, I'll explain the solid design principles. But these are all called as the microservices now. Okay, good. So we were understood the microservices. Let me show you the source code, how the microservices will be. A moment of time, let me show you the source code. For example, here, sorry, my bad. Trainings, microservices patterns. Let's see the, let me show you the source code of it. See this. There is a product service, there is a category service, there is a commons application, which is using by this category service and then the product service. So this category service, product service earlier will be as part of this back office application. Earlier as part of this back office application. Possible. Let me try to open this back office applications pom.xml file. So it is a Spring Boot application. The Shopify web parent. SDK. There is a parent for this project. Shopify web. This is not here. Let me showcase you the monolithic application first. Monolith SOA Shopify. See this. This is the Shopify Me parent, Shopify Me backend, Shopify Me front end. So that means what? This application, Shopify Me backend, Shopify Me front end. So this application is called as monolithic application, which contains all the modules inside in it. COM, Shopify Me, back office, series, all the modules, branding, category, customer, order, paging, products, report, security, users, shipping, all these are all there in a single project. This is called the monolithic application. So this monolithic application we decomposed into the microservices like here. So categories, having the categories specific JDK category specific source code only. See this COM Shopify Me categories. It's have only the category specific code. Only the categories microservice specific code. So if you can see the resource, there is only category REST controller. If you can see the services, there is only category service. If you see the what is a bean, there is only category bean. If you see the domain or model, there is only category domain, right? So all others are the application, enterprise application concerns that we were applied. Similarly, if you can see the source code of this another microservice called source code of another microservice called product contains only the product specific source code. See this brands, see this, it having the product brand resource and product brand service, right? Product brand domains, right? So it's having only related the code related to the products only, but not related to any other entity. This is called as what? Single responsibility service. So microservices are single responsibility services. Microservices are single responsibility services. Now, do you understand what are microservices? So microservices are small or tiny applications which will be self-executable. That means these microservices now will execute on their own. These microservices will execute on their own. Product will execute on its own, and then the categories will execute on its own. Let me try to showcase you that architecture, that as well. Just give me a moment. The working copy of the services I'll explain just in a moment. I will just showcase you the working copy of it and how we were applied the all other um, patterns is what I will show you. Let me open it. Okay, however, now as we got a understanding of what are microservices, these microservices having some limitations, some problems. That means in the maintenance of the microservices, we will get the challenges or we will get the problems. That maintenance problems of the microservices will be resolved using the microservices patterns. What are those problems? What are those maintenance problems? If we use the microservices, we will discuss. But before that, so I would like to explain you the concept of autonomous. Before that, I would like to explain you the concept of autonomous. Let it start. Yes, if you can see, there is a category service. And product service might be run in one more workspace. Actually, I might have taken like that. But if you can see this category service, which having its own JRE, which having its own Tomcat. Why? Because say Spring Boot application, by default Spring Boot is shipping with the one container enabled. Of course, 3 containers were there by default, but one of them will be enabled. So it is coming up with the Tomcat of its own, right? So this web is giving the Tomcat server of its own. So it's having its own JDK, own Tomcat, and also having the code related to only the categories, correlated to only categories, no other services. So this is called as what you know now, autonomous, because code plus infrastructure both are maintaining inside a microservice. Code plus infrastructure to execute that code or run that code. Source code plus the infrastructure like JDK or Tomcat or whatever the infrastructure required to run this source code is being maintained inside a single service. So that is called the autonomous. So microservices are autonomous. So which framework is giving in the Java this autonomous capability for microservices? The Spring Boot is giving the capability of this autonomous. That means when you create a Spring Boot application is giving the an executable server, that is the Tomcat, and Spring Boot application is pointing to the JRE, right? And maybe we can use a single JRE or the shared JRE, and we can customize the code related to one microservice inside the single Spring Boot application. So Spring Boot application or Spring Boot is facilitating us to have the one of the feature of the autonomous. So that is the reason in order to implement the Java microservices, Spring Boot is the framework most commonly or most familiarly used. But we can use any other, for example, Python. Python also can have these microservices, but the microservices should be a tiny application, self-executable, independently deployable, and autonomous. So if any of the microservice will satisfy, if any of the service will satisfy these these three characteristics, and if it is satisfies the single responsibility per service design principle, then we call it as a microservice, right? So microservices can be implemented in any of the programming, no matter whatever the programming language is. So microservices are called as the polyglot architecture, right? So if you can understand, if you got the concept of this, what is microservices, then we also can see the little bit history around the microservices. So microservices were not evolved. Sorry, microservices were not invented. Rather invented, microservices were evolved. That means what? Microservices are not new. The concept of this microservices design, like what I have explained to you, that means decomposing this entire application into small tiny applications. Small tiny applications. The small tiny applications are now called as the microservices. So this architecture is not new. This architecture was there since long time, but applied the concept called divide and conquer. Divide and conquer. We in 2010, when we started working, we used this kind of model, divide and then conquer model, but we don't know as they are the microservices, because no term called microservices was there in that time, right? When we worked on the divide and then conquer, divide and then conquer, concurrency, way back around 2010. But we use the same concept, but there it was called as the divide and then conquer principle. Later in time, that divide and then conquer principle have been evolved as a microservice. So how the term microservice came into the picture and how it has been evolved, all those things we will see tomorrow. So that's all for today about these microservices and then monolithic application, and what is microservice, what is monolithic application, how microservices are solving the problem of the monolithic applications. Are we clear? Are any questions for me? Are we clear? Okay, any questions for me? Fine. If no questions, then that's good. Let us connect back tomorrow. Any questions?
Sir, what is the course fee?
Okay, the course fee is 3,000. So let me able to write those particulars. Course fee is 3,000 INR. Course duration is 30 days, meaning 20 to 30 days it will take. And then the timings are every day 7 a.m. 7 a.m. Classes will be from Monday to Saturday. Maybe any one of the class might be skipped if I have any office conflicts and all. But if any such missed will be happened, then I'll take little longer time on Saturdays or maybe the Sundays. So timings are 7 a.m. What we will give? Recordings. Recordings will be provided. With the validity of 60 days. With the validity of 60 days. That means 30 days is while the course is happening, plus 30 more days we will provide the recording. And then material, soft copy of the material you will get. So soft copy of the material. So soft copy of the material meaning, if you can see this microservices patterns, I might have shown you, right? Let me open the classroom. In a moment of time, I will show you the material, how you will able to get it. So the material you will be able to get it using this Google Classroom. So you will be added to this Google Classroom, and you can directly download the material, view the material. So a lot of material I already have uploaded. Just you will be provisioned to this Google Classroom. See, resilience 4J patterns. So what are resilience 4J? Everything I was given, and cross-cutting concerns. What are the cross-cutting concerns? Observability patterns, right? What are the observability, and then the integration patterns.
Sir, on a different note, uh, do you have Spring Boot microservices upcoming class
Upcoming class, it
on
might
Spring Boot
take.
and microservices?
Yeah. Actually, we have started the Spring Boot in last week, meaning the Spring Boot microservices batch at 8:30 a.m. was started last month, but we completed the Spring Core and then started the Spring Boot in the last week only. So if you want to join, you can join there. But if you wish to join in the another new batch, it might take 30 more days probably. Okay. Yeah. So all the material that you can get from the Google Classroom related to each and every pattern. Plus already the entire source code I was already uploaded. So this is the source code of this microservices patterns. So what are the patterns will be covered, and how the patterns, what are the patterns will be covered, why we are going for these patterns, what is brownfield application, what is greenfield application, what is a bounded context, what is domain driven, all those things let us discuss tomorrow. Okay, so this is the course content. This course content I will give to our management so that they will publish the same course content in our DURGASOFT website as well. Fine. So that's all for today. Any questions for me, folks? Yes, we are going to code these patterns. Correct. We are going to code these patterns. Yes. Pattern is the solution, right? So how do we implement? Using the Spring Boot, we will implement these patterns. Any questions? Okay. If no questions, then I'm stopping my screen share. See you tomorrow at the same time. That is 8 a.m. Thank you so much.